Hey, my name is Forrest. Welcome back. So this is more or less a crash course in Git. Arguably one of the most important tools or most used tools we use as software engineers. It's an open source distributed version control system. And fun fact is developed by the same guy who created the Linux kernel, Linus Torvalds. And this isn't overly complicated. It is a version control system. It controls the versions of your project so you can reference previous versions whenever you want. It's like when you're writing a paper for school or something. You know, you have your rough draft and then you turn that in and you have to make some changes to the rough draft, but you want to keep that version of it that you already turned in. So you save the next one, save as rough draft v2. And then now if you want to keep that one, you do rough draft v3. So now you have 3 versions of the rough draft and now it's time for your final draft. So then you'll save as that. So that way you can have all of your previous rough draft versions as well as the final draft version. Oh, but you forgot something, but you want to keep that version. So then you do final draft v2. That's what it is. All of a sudden you have 5 versions of this paper that you're writing saved. And then you can revert back or reference any previous version that you have saved. That's version control. You've been doing it your entire life, just not in a proper system. Although I guess now if you use like Google Docs, it has version control built in, kind of, doesn't it? Doesn't have like a history of changes anyway. And the reason I said distributed version control system is because, well, instead of you just working on a single project locally and you're the only one that can work on it. Instead, how you work as a software engineer is that you have some sort of remote repository on a platform like GitHub or GitLab or Bitbucket or anything like that. It stores your code base in a remote repository, so that way your dev team of, let's say, 5 people can all clone that remote repository onto their local machines, and then you can all work independently on the same code base without messing up what everybody else is working on. And then once you have written your code that you want to be part of the remote repository, the code base itself, then you will push that up. But it will make a lot more sense if I can show you how all of this is done. I just wanted to give you an overview so you can kind of get a mental mapping of it before we actually dive in. So if you use an IDE or code editor, it probably has some sort of version control, or in this case, we're calling it source control, built in. So if we were to make a change here and save it, you can see that there have been changes to this file, navbar.jsx, and we can see those changes right here. We deleted this semicolon. We don't actually want to do that. Just wanted to show you as an example. However, it feels way cooler using the terminal here, so that's more or less what I'm going to do, and then I'll reference back to this source control over here. Just know that this source control, you can actually click these 3 dots right here, views and more actions, and you can see a lot of the very commonly used Git commands: pull, push, clone, checkout to, fetch, commit, changes, staging, and things of that nature. Anyway, so if Git's not already installed, what you would want to do is sudo apt install git-all. And this is if you're on a Debian-based distro like Ubuntu, which is what I'm using with WSL2. If apt doesn't work, or if you know you're on a different distro, then DNF is probably what you're going to use. Or if you are on Mac OS, then you're going to go ahead and use Baru. And if you're on Windows, well, install WSL2 and get that set up with Ubuntu. That's the only advice I give for that. Now we'll do something you should only have to do once, and that's set up credentials. So git config -- global credential.helper store. And what this will do is the first time you interact with a remote repository, what happens is that you have to put in your credentials, your username and your password. And this store right here will store those credentials in credential helper, and you will never have to do this command again, and you will never have to put in your credentials to access a remote repository again, because it'll just use this credential helper file right here. Now, the way I do it when building a new project is I set up the remote repository in GitHub first. So I'll come right over here, create new repository. I'll give it a repository name of learn git. I am going to make this one private, and then I'm not going to add a README file because I want this repository to be empty. And then I'll come on down here, create repository, and then you can follow these commands right here, where you create a new repository on the command line, a local repository. Remember, this is the remote repository. The one that'll be on your machine is a local repository, which is very straightforward given the names. And if you have an existing local repository that's already initialized and everything, you just follow this right here, where you connect to the repository and push to the branch. Or let's say you have an existing remote repository but not a local repository, you would just come to the repository, click on code, and then you would want to copy this SSH right here. This is the repo URL. And then where you want that project to be, you would git clone and then paste that repo URL. And what this will do is it'll pull down the entire code base, initialize a local repository for you, and then connect to the remote repository all with this right here. However, I do it a little bit different than this. Not completely different, but a little bit. So what I've done locally here is set up just a little simple Vite project with the React and TypeScript so that we have, a local code base. But as you can see, there's no Git repository local yet. What we're going to do is set everything up locally so that way we can push that empty repository all via the command line over here. So what I want to do first is initialize the local repository with git init. And then as you can see right here in source control, now we have all of this. As you can see, we have all of those code files that are in our working directory that will then need to stage and then commit. And then once we commit, they will be removed from this section here. And what I want to do is git add period, which adds our changes here in the working directory to the staging area. And you can see what it's doing right now. See, these are now staged changes instead of just changes. And what the staging area is for is to store information about what will go into our next commit, which is what we'll do now. And by the way, I only keep referencing this just as a visual way for you to understand what is happening. Typically, you're not going to be referencing that if you are in the terminal. You'll only be referencing this over here if you are using this over here, which by the way, see, I can unstage all changes, and now that just undid the git add plus, or sorry, git add period. And then if I wanted to actually do the git add period, in other words, stage all of those changes, all I would have to do is hit that plus right there, and that's doing this command right here. And the period just adds all of the modified files, but you can specify which files if you want. And then what we can do is git status. You don't have to do this, but git status just to see changes to be committed, which is everything these are all of the modified files that we just added to the staging area. Git status is your best friend. It'll let you know of what's staged, what's not, and if there are any untracked files. So just keep that in mind. Now, in order to commit these, we want to git commit -m. The -m is saying, hey, I want to include a message here, and that message goes in quotes, and we're just going to call this one initial commit. Now, when it comes to a commit message, we want the message to be descriptive to what we did. The initial commit, that's kind of, tradition. Initial commit as the first initial commit is tradition. But if I wanted to, let's say, maybe I should have not done that yet. Anyway, git commit -m. We have nothing to commit right now, just doing this as an example. If I wanted to, let's say I fixed a null pointer exception in user login. That's what I'd write as opposed to fix bug. Because what was that bug? You want to be able to describe exactly what you did with as few words as possible while still making it clear and specific. Because fix bug is what you did, but it wasn't specific. There are also conventional commit guidelines. You can actually see those right here, whereas they really like this format. If you have a feature and that feature is an API, what is that API specifically? Send an email to the customer when a product is shipped. Or if we added a feature, a new language, we added Polish language. So some people say you want to, do something like that. Or if you fixed, login, resolve race condition in login flow, then you would write it like that as well. I don't do that, but some people like to do that. Now, the commit that we just did, that we met, the message for it was initial commit, that is still only on the local repository because we haven't pushed it to the remote repository. In fact, we haven't even connected to the remote repository. But we can actually see the commit history, local commit history, by using git log. And this is the commit hash right here. And it is indicating that this is the head of the master branch. This is where we're at right now. And that is the message right there. Now, in order to connect to that remote repository, what we do want to do is git remote add origin. Actually, this is the exact command that we're doing, which is the same as you can see right here. But this is our repo URL, a repository URL. So git remote add origin repo URL, enter. Now we're connected to the remote repository. And what we want to do is push the commit, which is git push u origin master. And when we do that, as you can see, it has pushed our local repository and those changes that we staged and then committed. So it pushed our commits up to remote repository. And now you can see all of those here. Now, let me explain this command right here for you. U is set upstream. So what that does is it configures this local repository, this local branch specifically, since we are doing origin master, this local branch to track the remote branch. So you only need to do this once, this right here once, and then origin is what we named the remote repository. So that is what we referenced locally in order to access that remote repository. And then master is the name of the branch that we're pushing to. And in this single instance, we're actually naming it for the first time. Now I said the term branch. What's a branch in Git? Well, let's say you want to add a feature, and that feature consists of 5 to 10 commits. So what you just saw as initial commit, that was one. But let's say you wanted to add a feature for login, and you don't want to just do one giant commit. You want to be committing along the way so you have that history. So instead of committing every single little change to the master branch that everybody else is using as well, what you want to do is create something like a feature branch. And in order to do that, what you would do is git branch feature login system. Let's use that for example. And then you can use just git branch without any name after it in order to see what branches you have. And as you can see, this asterisk right here is indicating that we are on the master branch. So what we can do, there's two different ways to do it. I think git switch is technically the new way, and then git switch to feature. And now we switch to branch feature login. So if we were to run git branch again, you will see that feature login system. In this instance, it's green. I don't know if all terminals do that, but just look out for the asterisks. That will indicate what branch you're on so you know which one you're working on. And when we created git branch feature login system, what happened is that we created a new separate version of the master branch. So this branch isn't empty. It is right now the same exact thing as the master branch in terms of the code that is on it. And every change that we make to it, it'll be occurring on the feature branch as opposed to the master branch. The master branch will be staying the same, and then the feature branch will be getting new and new code. So now we can make the changes, do all of those commits, we can test it, and then once everything is all good, well actually let's do it. Let's do something over here. Let's pretend that there are no red lines. Vite plus React plus TypeScript. Okay, so we made that change, and you can see the change right here. And what I'm going to do is the same thing all over again. So what do we want to do now? We are on the feature branch. We want to git add dot, or again, we could do, let me look at git status. So we've modified source app tsx. So what I could do, which I never do, but some people say you should, git add this modified file right here, source app.tsx, and you could do it like that. I like to use a period because typically I am committing all of the changes, but that's not always the case. Git commit message change hero text, because I think that's what I did. And then what I'm going to do is git push u origin feature login system. And as you can actually see, yes, I made myself disappear because I was in the way, but as you can actually see right here, what I described earlier about that upstream, I did say that you only have to do this once. Well, we are on a new branch, so we're setting a new upstream. For the master branch, we only set it once for that. For here, we only need to set it once for this. But so branch feature login system set up to track remote branch feature login system. And this actually created that remote branch. We pushed it, it created that remote branch. That's all you have to do. And origin is just saying in that remote repository again, that's what we named it. So if we were to come over here, you can see that feature login system had recent pushes 3 seconds ago, and then we can compare and pull request. So what did I say before? Every dev on your team is going to be working on their own, let's say feature or fixing a bug, but in this instance, a new feature. We wrote the code, we did all of these different commits. Well, we only did one, but pretend we did 5 or 10, and now we've completed this, we've tested it, and then we're saying, okay, we think this is good. I push it up here, And then what I want to do is actually see, okay, it's able to merge. There are no merge conflicts, which is a good thing. And then I can create a pull request. And what creating this pull request will do, it'll indicate that I want to merge one commit or however commits, 5, 10 commits into master from this branch. So basically I want to merge this entire branch into master. We have no conflicts. And what I'll have is another developer on the team review this code. They'll review the code. Okay, if it's all good, then they'll go ahead and merge pull request over into the master branch, merge pull request, confirm merge, and then is successfully merged and closed. And then in theory, you could delete the branch because you no longer need it. However, now when we come over to git switch master, see, now we can see that wait, what? I spelled that wrong. Okay, we can see we're on the master branch now. We're actually not in line with what is on the remote repository. We're actually behind. So what we'd want to do is pull those changes down. Since everything is in line already, we have no changes here. So as long as the master branch is the same and the only change is on the remote repository, you can git pull origin master, which as you can see, it pulled one file change, 2 insertions, 2 deletions. And that was the change from our feature branch that we merged into our master branch remotely and then pulled down locally. And what git pull actually is, git pull is actually git fetch, because we're fetching that information and then we're merging that change with our local code base. Now, one command I want you to really try is git skillshare. That'll give you a 1-month free trial of Skillshare Premium. Well, not really. You have to click the link in the description for that. Skillshare is an online learning community for creatives where you have access to a litany of courses that can teach you programming concepts like OOP or web dev, and business and marketing like these courses here. Or maybe you're a fan of MKBHD and want to become a YouTuber because he's made a course all about that. Skillshare has something for everyone, from beginners to professionals, and this summer, Skillshare is offering the first 500 people who use my link in the description a 1-month free trial. So get started learning a new skill today via a class on Skillshare or a complete learning path. Big thanks to Skillshare for sponsoring this portion of today's video. Now, when you inevitably mess up, because you will, you'll commit something you want to undo, or even worse, you want to remove the history of the commit altogether. We've all been there, it's okay. It's also kind of one of the points of why we use version control in order to revert back to a previous version, maybe because you broke something. It doesn't matter the reason, we can do it. That's the whole point. So in order to get to a previous version of your code base, well, there are a million different ways to do it, and it's one of the issues with Git, and anyway, it's slightly annoying, but whatever. One way to do it is git revert commit hash. So let's say hash. So whenever you see brackets like this, that means you want to replace all of this with whatever is said inside the brackets. So in order to get the commit hash, we want to go to git log. And this right here is the commit hash, and this is the one we want to be reverting. And then you just hit enter if you want to see any commits before that. But this is the one we want to be reverting. So we can come here, we can copy this. I'm going to end that, clear, git revert, paste the commit hash, and then you'll get this file. We want to revert change hero. This reverts commit. This is the previous commit. So if I wanted to name this something else, I could change this text right here, but instead it's all good. So I'm going to Control X. And as you can see, we have reverted that previous change. So if we come over here and git log, it doesn't remove it in the commit history. So as you can see, this is our initial commit. This is on a different branch, so let's ignore that for now. This is us merging that branch. So this is the second commit on origin master. And then this is the final commit and where we're at right now, which is reverting change hero text. So what should be in our code base is that change that we made previously should not be there. Remember, this was plus TS. It is not there because now we have reverted back to the same version of the code as what we had in our initial commit because we undid the commit between it. Now, what if we wanted to remove this entire history. So we made the change and then we undid the change. So we did the thing and then we undid the thing. What if we wanted to just remove all of this stuff up here and just go back to the initial commit in our master branch and delete the commit history? Well, we want to copy the commit hash of the commit we want to reset to. So we want to go to initial commit. Here we were reverting this commit, so we pasted in that commit hash. Instead, we want to go to this one, reset to this one, so we're going to copy this commit hash, and then we're going to run git reset hard, so it doesn't ask any questions. And then we're going to paste in that initial commit hash, enter. Head is now at that, git log. As you can see, the only commit in our commit history is this one right here. Now, if you wanted to remove all of those other commits from the remote commit history, this is only local. If you wanted to remove it from the remote one, you would do git push force origin and then the branch. So master in this instance. And if we did that, we come over here, we will refresh and it deleted those other commits. Typically, some people think this is cleaner, and in some instances it is, but it deletes all of the other versions that you had, and you only want to do that if you're the only one working on them and you know for a fact you do not want those versions. If you are working on a repository with others, and the branch I'll specify with others, don't delete any of their versions. They won't like that very much. Now, there is one thing that I did not mention, and that is, well, what if I want to revert to the initial commit? Or reset to the initial commit with this right here, commit, with this command right here. But I have changes existing in my working directory that I want to keep. Well, in order to do that, let me come over and actually make some changes. So vite plus react plus that. I don't want to do the same thing as before so it doesn't get confusing. So we have these changes now in our version control. Well, what we would want to do is we would want to git stash, and it saved the working directory in index state, work in progress on master. And as you can see, we have no changes in the working directory because it saved it somewhere else. It stashed it away, and then we could come in here and run this reset. It would reset it all back. I'm not going to do it because we already did that. And then you would come in here and git stash pop, which puts that modified file back into the working directory. It just kind of removes it for a second, lets you do all of this stuff, and then you put it back. Stashes it, pops it back in. Done. Now you can also do that when you're pulling. So when you remember we did git pull origin master, when you do this and you had the changes, you could still do the git stash, then this, then git stash pop. And that is where I'm going to leave it, because while there's a lot more to learn when it comes to Git, and there are some aspects of Git that is just super poorly designed. And that's not just me saying this, this is common knowledge, but it's a very useful tool. Learn as much as you can. This should get you started, and this is probably what you're going to be using 90% of the time. And well, I may be missing one or two things, but this is all I'm going to go over for now. I hope you enjoyed it. If you did like the video, consider subscribing if you like content like this, and I'll see you on the next one.